Hello everyone, welcome to today's class. Today we have this Olympiad challenge before us here. We have been asked to solve 2 to the power of a plus 4 to the power of b plus 8 to the power of c equal to 148. What day is the value of a, b, and c that will satisfy this equation? Very easy. So let's take our solution first. Okay, now if you look at this equation carefully, we discover that 4 and 8 can be expressed in base 2. So let's go ahead and express them in base 2. So this will give us here 2 to the power of a plus this will give us 2 to the power of 2 all to the power of our b plus 2 to the power of 3 all to the power of c, everything equal to 148. Okay, all right. Now, according to the law of indices, which says that if you have your p to the power of a, b, this is same thing as our p to the power of b or to the power of a. Okay, so if we succumb to this rule here, we can rewrite the exponent here and here. So this will now give us here our 2 to the power of a, plus our 2 to the power of 2b, plus our 2 to the power of 3c. This is equal to 148. This has not really changed anything. There we go again. Now I want to factor out 2 to the power of a from this expression here. That is only the left hand side. Okay, so if we do that, this is going to give us 2 to the power of a bracket 2 to the power of 8 into 2 to the power of 8. That will give us 1. So we have here 1 plus, then if we do same thing here, this will give us 2 to the power of b minus a. Then plus this will give us 2 to the power of 3c minus a. Again, then we can put this in brackets equals to 148. Are we in order? Yes. Let's look at the term on the left hand side of the equation here, which is 148. We can express 148 as 4 times 37, right? Good. So let's go ahead and express that. So this will now give us here 2 to the power of a bracket 1 plus 2 to the power of 2b minus a, then plus our 2 to the power of 3c minus a close bracket is equal to our 4 times 37. Okay, now let's look at this carefully again. If we look at the left hand side of the equation, we discover that this is going to give us even, right? This is even. Now if we look what we have in here, this is going to give us odd. Why? Here, anything, if you have 2 raised to any number, that will give us even. And yet 2 raised to this will give us even, 2 raised to this will give us even. So even plus even will give us even number. But when you add 1 to an even number, automatically changes it to odd number. On the right hand side, 4 is an even number. Okay, so this is even, but 37 is odd. So with this, we cannot equate odd to odd and even to even. So let's take this first case, this to this. So this now implies that our 2 to the power of a is equal to 4. And 4 could be written as 2 to the power of 2, right? So since the bases are the same, we can equate the exponents. So therefore, we now have our a is equal to 2. So this is the value of the first variable in the equation we have in there now. So what we do now, we go ahead and equate the odd to odd. So let's equate our odd here. So we're going to have here 1 plus 2 all to the power of 2b minus a, then plus our 2 to the power of 3c minus a equal to our 37. Right? Good. So what we do next here is easy. We move this constant to this side of the equation. So we left here 2 to the power of 2b minus a plus 2 to the power of 3c minus a equal to 37 minus 1, which is equals to 36. Okay, we can rewrite this expression again with this minus here, right? So if we rewrite this, this is going to give us here 2 to the power of 2b all over 2 to the power of our a, then plus 2 to the power of 3c all over 2 to the power of a equal to 36. Easy. We have solved for the value of what? A already, which is equals to 2. So if we replace that here, this will give us 2 to the power of 2. And 2 to the power of 2 will give us 4. So again, we can now rewrite this as our 2 here to the power of 2b all over 4, there plus our 2 to the power of 3c all over 4 equal to 36. Easy. We can clear off the denominator by multiplying both sides by 4. True or false? So let's do that. So if we do that, here we'll be left with 2 to the power of 2b plus 2 to the power of 3c equals to 36 times 4. This has not really changed anything. Now let's look at the left-hand side of our expression. Again, I want to factor out 2 to the power of 2b from this expression we have in here now. So if I do that, this is going to give us here our 2 to the power of 2b bracket. If we use this to divide this, we're left with 1 here, then plus, this is 1 please, then plus, if I use this to divide this, it's going to give us 2 to the power of 3c minus 2b close bracket equal to 36 times 4. We get something here. Recall we said that 2 to any number will give us even number. So the whole of this is even number plus 1 will give us odd number. So let's mark it out here. So this is even number, while the whole of this is odd number. But let's look at the right hand side of our equation. Now we are having this to be even number and this even number. So what do we do? Can we get odd number from here? Yes. We can split 36 down. And 36 will give us something nice. 36 could be written as 4 times 9. Remember that? Okay, so this will now give us 4 times 9 times the 4 in existence. So we can put this and this together. So let's go ahead and rewrite everything here. So we're going to have 2 to the power of 2b bracket 1 plus our 2 to the power of 3c minus 2b close bracket. This is equal to our 4 to the power of 2 times 9. Okay, let me write this now very well. Okay, so we now have here even. This is even, please. Then here we now have this to be odd. Okay, then this side we have here to be even. And here we have this to be odd. All right, so let's equate even to even number, odd to odd. Our 2 to the power of 2b is equal to 4 to the power of 2. So again, we can rewrite this as 2 to the power of 2 is equals to 2 to the power of 4. Because 4 to the power of 2 will give us 16, and 2 to the power of 4 will give us 16 also. So this might end up giving us 2b equal to 4 divided by 2 divided by 2. So this leaves. So we now have our b is equal to 2. Oh, what a coincidence. So our a and b are having the same value. Okay, 2, 2. So let's go ahead and solve for our c. Will c give us same value? So we'll get that from our solving. So let's go ahead and compare the aspect of odd to odd now. So our odd part we have here to be our 1, 2 to the power of 3c minus 2b. This is equal to our 9. We can now move 1 to this side of the equation, so we're left with 2 to the power of 3c minus 2b, right, equal to 9 minus 1, which is equals to 8. So 8 can be written as 2 to the power of 3, right? So we now have here 2 to the power of 3c minus 2b is equal to 2 to the power of 3. Okay, so what we do next here, since the bases are the same, let us leave the system, And here we're left with 3c minus 2b equal to 3. Again, we'll solve for our b already, which is 2. So we can replace our b with 2. So this will now give us 3c minus 2 into 2 equal to 3. Good. So this gives us 3c minus 4 equal to 3. We can move this to this side of the equation to give us here 3c equal to 3 plus 4, which is equals to 7. So we're looking for c. So we divide both sides by what? Our 3. So we equally divide this side by 3. So this leaves the system. So we're left with c is equal to 7 all over 3. So 7 all over 3 is the value of c. In other words, we have a different answer to our c. So we now have here, therefore, our a is equal to b, which is equal to 2. And our c is equal to 7 all over 3. So these are the roots to our challenge. And if you plug this into the original equation, you're going to have the equation, the left hand side to be equal to the right hand side. But that's why I done a little check to this equation. But on your own, just do the check and drop a comment in the comment section if they actually satisfy the original equation. So this marks the end to this simple challenge. This is my prayers, and we love you for being there. Thanks again and again. Bye. We will see you in the next video.